Hello everyone and welcome back. Let me start with a simple question. Have you ever noticed the roof of a house or the frame of a road sign? Most of them use the same strongest shape in geometry, the triangle. A triangle is nothing but a closed figure formed by three intersecting line segments. It's the simplest polygon you can ever create. It has three sides, three angles, and three vertices. For example, in triangle ABC, written as delta ABC, the sides are AB, BC, and CA. The angles are angle A, angle B, and angle C. And of course, the vertices are the points A, B, and C. So remember, the moment you see three connected line segments closing a figure, congratulations, you have spotted a triangle. Now, let's talk about some fascinating properties of triangles. First, the most famous one, the sum of the three interior angles of any triangle is always equal to 180 degrees. In other words, angle A plus angle B plus angle C equals 180 degrees. Second, in a triangle, the side opposite to the greater angle is always the longer side. That makes sense. A bigger opening needs a longer side to connect it. Third, the smallest side is always opposite the smallest angle. And finally, here's a cool feature, a triangle is rigid. If the side lengths are fixed, the shape cannot be deformed. That's why engineers use triangles in bridges and towers, they are unshakable. Alright, let's classify triangles based on their sides. If all three sides are equal, that's an equilateral triangle. For example, if AB equals BC equals CA, then it's equilateral. And yes, all its angles are 60 degrees. If only two sides are equal, like AB equals AC, we call it an isosceles triangle. The angles opposite the equal sides are also equal. And if no two sides are equal, it's a scalene triangle. In a scalene triangle, all sides and all angles are different. So the rule is, equal sides always give you equal opposite angles. Now, let's look at triangles from the angle point of view. If all three angles are less than 90 degrees, that's an acute angle triangle. If one angle is exactly 90 degrees, then it's a right angle triangle. Remember, the side opposite the right angle is called the hypotenuse. If one angle is greater than 90 degrees, then the triangle is called obtuse-angled. Here's a fun twist. A right-angled triangle can be either scalene or isosceles depending on its sides. But it can never be equilateral because an equilateral triangle has all angles 60 degrees. Hello everyone. Before we dive into trigonometric formulas, let's agree on the standard way of naming triangles. We always name a triangle by its vertices in cyclic order. So, this one is triangle ABC now. Here's a neat convention. The side opposite a vertex is denoted by the same letter in small case. That means the side opposite vertex A is called small a, which is side BC. Similarly, the side opposite vertex B is small b, that's side AC. And the side opposite vertex C is small c, that's side AB. Angles and their opposite sides are always written with matching symbols. This simple idea keeps all trigonometric relations clean and compact. Quick insight, this universal system of naming sides and angles is what makes formulas like the sine rule and cosine rule easy to write and remember for any triangle in the world. Did you know that by just knowing the lengths of a triangle's sides, we can classify its type and even find its angles? Sounds magical, right? Well, that's the power of the cosine rule. Let's take triangle XYZ, where side XY equals 5 cm, side YZ equals 6 cm, and side ZX equals 7 cm. Since all three sides are unequal, we immediately identify it as a scalene triangle. Now, to find the angle at vertex x, we apply the cosine rule. Cosine of angle x equals 5 squared plus 7 squared minus 6 squared divided by 2 times 5 times 7. Simplifying, cosine x equals 25 plus 49 minus 36, all divided by 70, which gives 38 divided by 70, approximately 0.543. Taking the inverse cosine, angle x comes out to about 57 degrees. Since 57 degrees is less than 90 degrees, angle x is acute. Similarly, when we check the other angles, all of them are also less than 90 degrees. Therefore, the triangle is not only scalene but also acute angled. Quick insight: the cosine rule helps us classify triangles by their angles even when only the side lengths are known. Isn't that a neat mathematical shortcut? So let's wrap up everything we learned today. A triangle is the simplest polygon with 3 sides, 3 angles, and 3 vertices. We can classify triangles by their sides, equilateral, isosceles, and scalene. Or we can classify them by their angles, acute, right, and obtuse. We also saw the standard naming convention using small a, b, c for sides opposite to angles a, b, and c. And of course, the golden property: the sum of the angles of any triangle is 180 degrees. This is just the foundation. In the next part, we'll explore something even more powerful: how to check when two triangles are exactly the same or congruent. That's where the real fun begins.